Welcome everyone to Tofu Tech Talk. I have a very special guest today on this podcast science communication episode, and today is Star Strider. Please introduce yourself as much or as little as you'd like.
I am Starstrider online, pretty much anywhere that you can go looking for me. Because of mistakes made in my 20s, it is spelled with a Y, and I will be saying that for the rest of my life. In real life, I'm Dr. Pamela Gay. I'm a senior scientist at the Planetary Science Institute and the director of CosmoQuest, which is an online citizen science and science media organization that you can find right here on Twitch as CosmoQuestX.
Oh, would you be able to type it in the chat for anyone
Yeah,
to? I would
totally.
appreciate it, and I will give a shout out so that we can give it all a follow and check it out. And I'll say welcome in. Perfect. I will give a shout out to that. Okay, so your what? I'll ask this. What is kind of your education background and research about? If I can boldly ask.
You can boldly ask away. I have a PhD in astronomy from the University of Texas. I have never been one to know what I wanted to do when I grew up. So my master's thesis was on stars and star clusters. My dissertation for my PhD was on galaxy cluster evolution. And today I have migrated all the way over to planetary science, where I'm partnered with a variety of different researchers looking at the surface of the moon and other solid-ish objects in our solar system. I say ish because I just finished a bunch of work on the asteroid Bennu, which has about the consistency of a ball pit. And I'm not sure any of us would call a ball pit a solid surface.
Wait, Bennu isn't solid? Isn't that the one that was recently in the news with the landing of the probe?
Sort of.
Oh,
So the asteroid Bennu, it's about a city block in size. It's rather small, and it's what's called a rubble pile asteroid. So if you imagine a dump truck filled with boulders and pebbles and every size rock in between, gallivanting through the solar system and just dumping its load somewhere out near Earth's orbit, you have the asteroid Bennu.
mm.
And all these rocks are gravitationally held together, but the object has so little mass that the standard human being would exert as much force on the surface of Bennu as a piece of paper would on my hand. Now, when we went to go and grab a sample from the surface
Mm.
of Bennu, the thought was the arm that was extended from the rover would touch the surface, it would blast air, it would spin and suck up a whole bunch of pebbles and rocks into the collector, and in the process would bounce off and then fire jets to keep it going away. But those jets would be fired once it had already made a good bounce. The reality is, it touched the surface of Bennu, went through the surface of the Bennu, went 30 centimeters into the surface of Bennu, and then those jets fired. And were it not for those jets, we might have accidentally placed our spacecraft inside the asteroid Bennu, which is not where spacecraft belong.
Oh my days. That is, oh, you're such an amazing storyteller. I'm absolutely intrigued. We have loads of people coming in. Welcome, welcome in everyone. Sorry, we usually run ads for like 15 minutes, but we were a little bit delayed today. Apologies about that. Welcome everyone in. I am absolutely blown away already from the beginning. Kind of like space quicksand, Jimmy says.
A little bit rockier. I can imagine space quicksand. It sucks you in because of the moisture and the gravity pulling you down. This is much more literally a ball pit. The
Okay.
distribution of the rocks is not too different in size from ball pit balls. Yeah, this is death by ball pit.
Wow. Death by bomb. There could be a joke written in there very well. Oh, so your PhD research you said was in galaxy clusters. Now I don't know
Yeah.
if you want to talk about that. That sounds amazing. What exactly did you do with galaxy clusters? You were studying statistical things or
So
chemistry?
I I actually was so when you do research, you never know if what you're doing is going to be amazing or bleh. My goal, my raison d'etre, was to make it easier for scientists to find clusters of galaxies.
Okay.
What I thought I would do, and what I actually did, was we knew that if you looked at a single radio cluster, or sorry, a single radio galaxy, using an optical telescope, there's basically a 22-23% chance that you'd find around that radio galaxy an entire cluster of hundreds to thousands of additional galaxies. So the idea was if you had a 20-something% chance of finding a cluster around a single radio galaxy,
Mm-hmm.
that now that computers, I'm old, now that computers at this point were allowing us to do big data studies using databases, if we instead looked around the sky for places where instead of just one radio galaxy, there were like 5 or 6 radio galaxies in one small area, that those places would be significantly more likely to have galaxy clusters. This was our hope, our thought, our belief. So I spent months pulling data out of the Very Large Arrays catalog of sources. It was FIRST at that time was the catalog we were all using, looking for these overdensities using software, um, and then imaging overdensity of radio sources after overdensity of radio sources using the McDonald Observatory 30-inch telescope and 107-inch telescopes. And what we discovered was you actually only increased the probability of finding a galaxy cluster by about 3%, which is not meaningful, but you increased the amount of work you have to do by about a factor of 2. So, I discovered a way you absolutely should not go hunting for galaxy clusters. Absolutely should not. But somebody had to do this research, and that somebody turned out to be me.
I,
Um,
oh
yeah.
seven. We appreciate your work and effort. I love that. I love that. Just to kind of before you go, if you add any more points to it, it was my question, but also Jimmy stole my question. Is radio galaxy a particular type of galaxy? I'm assuming it's a method of detecting galaxies.
Yes, and it also makes it a special kind of galaxy. So
Okay.
your average galaxy, like our Milky Way galaxy, gives off the bulk of its light in optical and infrared light.
Mm-hmm.
This is the colors of light our eyeballs can see, that snakes can see, and that military uh, nighttime goggles allow you to see, basically. Now, there's a lot of different processes that go on with stars, with black holes, with everything else. And it turns out that if you have a ton of star formation going on, forming star systems also give off a lot of light in the radio. And if you have an actively feeding black hole, a black hole that has material spiraling into it
Mm-hmm.
that is crossing the event horizon, right before that matter falls into the black hole, it gives off a ton of radio light. So there are galaxies out there that are either undergoing a bunch of star formation or have an actively feeding supermassive black hole in their core, or both. And these galaxies give off a ton of light in the radio. And since the radio sky is, in general, a lot quieter than the optical sky,
Mm.
it becomes easier to find things in the radio. So start by going the place that it's easier to find a random galaxy, a radio catalog, and then look around those galaxies to see where there are clusters.
That's amazing. And is this still a technique? I don't know if that's a fair word to say. That's used to this day. Do you know?
Oh, so people will continue to always look around radio sources to see if there is a cluster of galaxies
Mm.
or anything else interesting going on. But I don't think anyone else is ever going to be foolish enough to go through all the hoops and hurdles I went through to look for clusters of radio sources.
Okay.
It just wasn't useful.
So before we move on to the subject, Jimmy is asking, would there be galaxies that are only visible in the radio light range, or is that too reductive? Is there
Um,
like
no, because stars. So the thing is that anything that is sufficiently warm like a star,
Hmm.
is going to be giving off light that peaks in either the infrared or the optical. And warm things give off this distribution of colors. So this is the classic Kirk shoots a rock with his phaser, and the rock heats up to red and then
Hmm.
eventually blue if he keeps shooting it with his phaser. The distribution of colors of light that that rock is giving off are going to extend across all colors, and then our eyes just see the colors that, well, correspond to its temperature.
Mm.
Hot things give off light in the reds, the blues as they get hotter and hotter. And stars are things that give off the bulk of their light between those red wavelengths and those almost ultraviolet blue white wavelengths. So galaxies are made of stars, and stars are going to shine. It's what they do.
Damn, that is, it's just so interesting to hear you say everything that you've spoken about thus far. Because how should I phrase this? I never even thought of asking these questions, if that makes sense. You're telling me something I would have never asked. Does that make sense? So it's fantastic to hear the input here. Um, oh, big a log of questions. But Jimmy just wants to finish off with saying, "Aw, no spooky, sinister, dark galaxies." Then.
No, not that we know of. There's some super faint ones out there, but they're also not shining in radio. They're just sitting out there darkly with their gravity pulling on everything around them.
Oh, and that's the whole discussion of, we don't see any matter there. Is that
Yeah.
dark matter and dark energy then? That's it.
Well, dark energy's everywhere, but it looks like there are dark matter dominated galaxies out there.
I'm going to get sidetracked if I ask now. If you have to take this opportunity, because we've talked about dark matter on my stream before, and my stance is this is not my field of physics. I'm in a different, completely area. But my field is obviously I would always give it away to the experts to say it. But it seems like, after reading as much as I can, is that there isn't the biggest general consensus out there on it. What is your opinion on it?
I think that, as so often ends up happening in science, we're going to discover the answer is more than one thing. That we're already realizing there was a new paper that came out, I think it was last week or the week before. It may have been a month ago at this point. Time no longer has meaning. Um, but the paper was discussing how there are intermediate mass and larger than expected mass black holes out there that could be up to 3% of dark matter.
Mm,
So a lonely black hole out there haunting the outskirts of galaxies, the cores of globular clusters. These dark objects could be part of dark matter. We know they aren't all of it, because if they were, we would see a lot of side effects from having all these black holes out there. But it's looking like they could be up to 3% of dark matter.
yeah.
We are getting information from galaxy clusters that are colliding and passing through each other, where we see the stars passing through each other and interacting. But even faster than that, it appears that the dark matter, which its gravity affects light from behind, the dark matter appears to be particles of some sort based on what we're seeing in these galaxy clusters. But then there's also research that is completely consistent with there also being an extra term to gravity.
Yes.
And it is entirely possible that some small fraction of dark matter is just planets out there that we don't see, that aren't attached to stars, that is black holes, a variety of different sizes that formed early in the universe. And that there's also an extra term to gravity, and there are particles like sterile neutrinos and axions that we're just starting to understand. All of these things can simultaneously be true in different proportions.
I was even going to say maybe even different perspectives, depending what you're looking for. Different things are weighted differently depending on what you're looking for.
Yeah, the center of a galaxy may have different ratios than when you're looking at the spaces between galaxy clusters.
Thank you so much for that in-depth explanation. I really appreciate that. So, if any of my lab rats ever give me sass about not knowing about dark matter, we just have a clip. We'll have a highlight of this explanation, just for that. I'll go through some of the questions, so it might be pulling us randomly back and forth. So, hopefully, we've
That's
kept
fine.
track of everything we've said. Did you have to be careful for accidentally confirming false positive for artificially generated radio waves? So, when you were talking about earlier, is that a problem?
No. No, because the gas in galaxy clusters is extremely diffuse, and it's giving off the bulk of its light in what's called the 20 centimeter wavelength. This is a special wavelength that hydrogen atoms left alone long enough are going to undergo this very rare flip that gives off light in a very specific radio color. And that's a protected wavelength, or at least it used to be. It's no longer clear what wavelengths we have to worry about satellites blasting our telescopes in. But
Oh.
at the time, that was a protected wavelength. And so we could do science knowing that we were only measuring what the universe was doing and not what some person trying to sell us something over a radio band was doing.
I see. Hopefully that is a good explanation, Zier. Wait. This is, I guess, a little bit of a joking question. I'm not sure. I have a minion that wants to be an astronaut. Okay, this might be Kerbal Space Program. Have you played Kerbal Space Program?
I have.
Perfect. What should be a good exercise to show him just how vast in distance galaxies and stars are apart? That's an interesting
Oh my.
question. And good. Oh, okay. So if you were like teaching a child or someone, how would you describe? Do you have a good description of explaining just how big the universe is?
No, because human brains just can't conceive things this big.
Mm.
There are a variety of cities out there that have solar system walk
Oh,
paths.
yes, I've seen those.
And so you can set up something that's a few city blocks in size that has you walking through the inner solar system, and then they'll point out that like 4 towns away is where Pluto's located. And then the nearest star is suddenly like out where the moon is located, depending on the scale of the system. And that starts to get it across, but then that's the nearest star, which is only order of magnitude like 4 light years away. I'm using whole numbers here, people. Now, our galaxy is order of 200,000 light years across, depending on how much of the gobbledygook in the outskirts you want to count. So to go from the nearest star is 4 light years, how do you now explain that something is that far away in a way that we understand? Because saying it's at the distance of like the Kuiper belt or something, that doesn't mean anything to any of us. The best we can do is start to scale things where we say, like, the Voyager spacecraft that left before mom and dad were even born is now out in the outskirts of our galaxy, of our solar system. And if we build a solar system that fits within our town more or less, our galaxy fits within our solar system. These are still numbers we just don't comprehend.
Hmm.
Human beings don't really understand anything over 1,000 at a fundamental level. We can start to get at tens of thousands or millions based on city sizes, but still, like, concretely, we're good to 1,000 and then it all stops making sense.
So it's pretty much impossible. We
Yeah.
talk in infinite, but we don't even conceive infinity either.
Our
So,
No, no.
mm.
Our brain likes things that we can count on our fingers.
I suppose just to kind of deter to another question, Jimmy kind of highlighted a few minutes ago. I've been having an existential crisis contemplating the size of the universe and the distance between galaxies. His question is, how do you cope?
So I like the fact that we live in a situation that makes everything here feel both so small and yet so important. We see at most 3% of our total universe.
Mm.
The visible part of our universe is at most 3%. It could be that we live in an infinite universe. We can only put lower boundaries on what we see.
Hmm.
We are the smallest part of that. But we are within our sphere of detection, the only intelligent life that has affected its planet to a degree that is easily seen.
Oh.
And when you start to realize just how alone we might be, that it could be that life just has a tendency to wipe itself out once it hits a certain level of civilization, or that it just disappears from interacting with the universe for some reason. We don't know why we don't see other intelligent life. This is the Fermi paradox.
Mm.
And the idea that we, in this moment of time, might be it. We have to protect what we have. There's no safety net. We're running with scissors through the universe, and that's a lot of responsibility.
That's very poetic. Yeah, I think you're referring a little bit to like the filter, the idea that um, if there is civilizations that are ahead of us, where
Yeah,
are they? They should be here because we're
exactly.
very visible. But chances are, if there were civilizations before us, they hit a line, whatever that line is,
Yeah,
whether it be multi-cell organisms or creating nuclear
yeah.
bombs that destroys the world, whatever it is. Um,
Right.
yeah.
And I understand, Jimmy. I live in constant existential crisis. This is just the life I live.
Lab rats, let's not panic. Relax. All right, all right. The space isn't real. It's okay. It's fluffy, fluffy, fluffy stuff. Everything's good. Everything's fine. Nobody panic. Thomas was asking, are you using the Kepler Space Telescope for your research? Do you use
No.
any telescopes, in fact, for your
Yes.
research? You do. Yeah, you do. Yeah.
I do, so most recently, the data I've been using, comes from the Lunar Reconnaissance Orbiter, which is orbiting the moon. We're using data from the CRS, which I do not remember what that acronym stands for. I just know how to pull my data. And also from the narrow angle camera. So that's the high resolution data that would allow us to see basketball players doing snow angel positions on the moon.
Wow. That we're kind of switching to talk about the moon. That is your current research, right? You do
Yes.
surface analysis of the moon. Is that correct?
It's mostly surface mapping.
Oh,
So I work with citizen science projects where um, software is, it turns out, the one thing that unites all the different areas of research that I work on is I'm a database programmer at the end of the day. And the research questions I'm answering are ones that get answered by writing the right MySQL query once you gather all of the data. And so what I'm working on now is writing software that allows other people to go through all of our myriad images that machine learning can't yet process and map out what are the features in these images. And then we can go through and we can find what are the scientifically interesting places to explore and the totally unhealthy places to try and land rovers. So we're looking to create hazard maps. We're looking to identify interesting places to explore. And what I'm doing is developing the software that allows everyday people to aid scientists in doing these mapping activities.
that is amazing. So basically, so I do lots of sailing. There's these like hazardous grids
Yeah,
for seas where there's currents, where there's bad deaths, like anything
yeah.
like that. So you're basically doing that, but for the moon.
Exactly, and also, like, a project that we just got funded 2 weeks ago, so we haven't started it yet because getting it funded is not the same thing as having the money available to use,
Oh no! Oh
but
no!
we know this is coming. Our moon used to be a extremely active place for volcanism. There were magma flows across the surface, and when I say that there was volcanism, there was also stuff that got melted due to asteroids hitting and melting stuff. So we have lunar melt from a variety of different sources, and we're going to specifically be training people to identify melted rock on the moon to help us map out these places that may have, for instance, lava tunnels, which are someday going to be the safe places for humans to live. We are looking at a future where we become the mole men and women of the moon because that's where the radiation protection is.
Mm. Okay, so underground is the thing,
Yeah.
or so not
Yep.
domes, not like not domes anyway.
Well, domes cost a whole lot of money and
Mm.
require a whole lot of equipment to build. If you find yourself a nice lava tunnel, and we know they exist on the moon, you can just move right in and seal the openings, and your home is provided.
There we go. This is just my lab rats are going to love this now. There's going to be a whole meme about having mines now in the moon. Anyways, so that's kind of the plan and prospect. Can I ask this the surfacing that you're doing? For two
Mhm.
questions. First of all, what kind of programming is it that you do? Just a pure interest of mine. And then the second of question would be, there's so many projects right now revolving around the moon and space travel towards the moon
Yes.
as news. Is there any big company or project that you're collaborating with?
So in terms of the programming
Hmm.
language I do, I'm using a LAMP stack, so it's Linux, Apache, either MySQL or MariaDB, depending on what server we're running on,
Oh,
and then Python and PHP. PHP is the language I use most.
oh.
It's just rock solid for writing websites. I know there's a lot of people who are like, but you should be using. I don't care. PHP was developed for web programming. I'm going to use the task built tool. Don't at me.
It's a
Um,
common enough discussion in the channel to what's the best programming language.
it all depends on what you're doing. There's so many options out there. And for us, this is the one that works best. But in terms of companies or anything like that, the research that I do is focused on taking existing archives of
Hmm.
data that was collected by NASA missions and processing it to do new science. So there is, at this moment in time, no commercial outcome of what I'm doing. And honestly, I am someone that wants to give my science away for free, which sometimes makes it harder to eat, but allows me to sleep at night.
That's such a sad statement of affairs of scientists around the world, isn't it? The whole
It
academia
is.
industry, and we won't go into
Yes,
that. I'll just get upset and riled up again. But
it's
that was
true. It's true.
perfect answer. No, that's amazing. I'll go through a few more questions. What would be the greatest technical achievement you would most benefit from your research? As in, what would you most want to advance?
So AI means a whole lot of different things, and
Ooh.
large language models are never going to solve any science problems. What we need is better computer vision. We need to be able to more effectively train computers to understand what things look like under a variety of different lighting
Hmm.
sources with a variety of different cameras. And it is my dream that we will someday be able to say, okay, we have trained this machine learning algorithm using this data set. We are getting ready to launch a camera that has a slightly different response. Its pixel size is slightly different, its response to color is slightly different. And instead of having to completely retrain the algorithm with a different camera, which is what we have to do today, I want there to someday be software that allows us to say, okay, when we switch between these two cameras, the images change in this known way. Figure it out for yourself. The same way our
Mm.
human mind is able to go, oh, you gave me more pixels, but I still recognize that's the same person, that's the same chair. Software isn't as smart as we are. And just that one simple thing of not having to retrain when we get new cameras would be amazing.
Wow. Yeah, no, that's a very interesting point. I'm well versed in microscopy imaging, all the kind of stuff. So
Yes.
not the moon, tiny, tiny stuff. And this is a huge problem. So many people work in
Yeah.
this in this field of machine learning, and it's
Hmm.
very slow. But you're absolutely right. That would really help significantly if it could be possible.
Yeah.
Jimmy asks, what would make a particular area scientifically interesting? So I suppose this, the whole stuff that's happening on the moon, probes landing,
Yeah.
and obviously your research with the mapping. What would be scientifically interesting? Like what could possibly happen?
So uh the number one thing that makes something scientifically interesting is you look at it and you're like, I have no idea what the insert expletive it is that I'm looking at. These these things that we periodically discover that are utterly unexpected, those are the most scientifically interesting. My favorite example of this is there are features on the moon that we're starting to understand are related to magnetic fields, and we don't know why
Mm.
the magnetic fields are there. These are called lunar swirls. They're places where the surface is very smooth, and there are different colors of minerals that paint these swirly patterns on them. And we believe what's happening is the different minerals have different magnetic properties, and interactions between solar wind and these minerals and the magnetic field have led to these coloration variations. Last week, someone was telling me that it comes down to when you have a magnetic field, the charged particles from the sun that would otherwise slowly change the minerals sitting on the surface of the moon don't get to the surface of the moon because the magnetic
Mm.
field deflects them. And so we're seeing the moon's periodic random ability to deflect charged particles that would otherwise be painting its surface a different color. And
But
that's
only
super
in certain
cool.
areas, like not even on the surface of the moon,
Yeah,
just in little niches.
exactly. And so when we first saw these swirls, it started with, what is that? That is weird.
Alien
And then
shenanigans.
yeah, well, I mean, there's always going to be someone who claims it's aliens. But then over time, people had to figure it out because we couldn't go there and look. And we think, but we don't know
Mm.
that it's magnetic fields. And I'm sure there is some researcher out there who just wants to go out there and start taking core samples to find out, is there a source of magnetism beneath the surface that we can sample?
Mm. That would be and do you know how strong these magnetic? Oh, sorry, they don't know actually if it's magnetic currents. They're just
We th-
guessing anyway.
we think it's magnetic.
Okay,
We can measure magnetic fields, but
it's
like
too
we
weak.
don't know what's causing it.
Okay,
Yeah. So they're just weird.
wow.
And every time we get a new and better camera, we find more weird stuff that we did not know would be there. The universe is just far more creative in what it manifests than any of us who are trying to predict what we'll see.
Mm. Oh, that is actually so cool. You sharing that story, which is perfect in theme because the last thing we studied was magnetism with the lab rat, so that's
Oh,
perfect.
perfect.
um, I'll go back to Thoughts question in a couple of seconds just to keep on track of the technical questions. Quaikeek is asking, so this was about your imaging topic, the whole discussion we had about machine learning.
Yes.
So this is a bit technical question. Um, when describing the difference in cameras and retraining machine learning, what is the stumbling block there? My brain just says that apply a filter to transform the image data, since the difference are
Yeah.
quantifiable before it reaches ML model. I assume there's some hidden complexity here.
So what you're dealing with is, in general, data gets better and better over time. So you don't want to downgrade your data to match what was previously trained. If you do that, you're going to miss things in the background.
Mm.
So consider, for instance, an image coming off of the Hubble Space Telescope where you're trying to identify all the galaxies in the image. You're dealing with significantly higher resolution because you have a bigger mirror. And you're dealing with a slightly different wavelength of light than what we've been able to see before. And the combination means that, yes, there are things that are recognizably planetary nebula. There are things that are recognizably galaxies, but they're going to appear in different colors. And you're going to see the things that are nearby in such higher resolution that you're now seeing extra features, and those extra features cause computer vision to go, no, that is something else. But the ones in the background that are extremely small, those now look like what the software is used to a galaxy looking like. So if you down convolve the image to match what was used in the training data, you're going to lose the background galaxy. It disappears. And while that foreground galaxy might now get recognized, you don't have the potential to start to be able to say, okay, so the software has now pulled out all these galaxies that we see extra details on. Let's now take the software to the next level and train it to do something with all these extra details. So ideally, you want to be able to say, okay, get with the game. Planetary nebula are now going to have this distribution of color. Galaxies are going to have this distribution of color. You might see these extra features. Ignore the extra features until we tell you to, which is what you do with a human. I want that same ability
To train.
that I have when talking. Yeah. Yeah.
True AI, basically. One day. Well, Kwaikwai jumps in to say thank you. That explains very well, very well. That was a fantastic answer. We were talking about life on different planets, and Forward Thoughts is asking, do you think there is life on a distant planet, in a distant galaxy? I suppose we talked about, in our galaxy, that we're in this weird filter situation. Are we in the forefront, or what's the kind of thing? But do you think there is life in others?
So I think we need to be careful to say intelligent life adapting its environment so it can be detected. Because just last week, we got further evidence that there may have been microbial life on Mars. I firmly believe that within the next decade, we are going to find evidence of a microbial past on Mars. There was a period in our solar system where Mars, Venus, and Earth all had climates with moisture, temperatures, and chemistry conducive to life forming. And so there could have been a time where all three worlds had stromatolites, had bacterial mats, had things that we should be able to detect in the fossil record, at least on Earth and Mars. There are worlds within our solar system that have subsurface oceans that have heat, have chemistry, have thermal gradients, everything, again, conducive to life.
Recipe, yeah.
No one's going to say that there are probably sub-ocean civilizations on Europa. But there is a good chance that there is life in some form on other worlds in our solar system. What we haven't found evidence of anywhere is technology, technosignatures that are detectable. And it's that lack of technosignatures that leaves us wondering if we're the only civilization. I choose to believe, but I don't have a scientific justification, that with so many more planets than stars in our galaxy, that somewhere out there, there should be life that had a chance to make it past just microbes. Somewhere out among all the galaxies, all 200 billion to 2 trillion that are in our visible universe, there should be other civilizations, even if they're only at the same stage we're at. I just don't know if we're ever going to find them. To quote from Contact, it's an awful waste of space if there isn't more out there.
Do you know at what what's the word? At what era they have to be in for us to be visible? Like, it has to be past industrial, right?
So we can start to say there is probably life on that world out there once there are plants and other life forms capable of changing the ratio of chemistry in an atmosphere. You don't end up with oxygen-rich atmospheres unless there is something producing that oxygen. Oxygen is just way too reactive. It likes to be part of other molecules.
Mm-hmm.
Now, in order to start to say there's technology, you need to start seeing the lighting, the radio waves, the pollutants, for lack of a better way of putting it,
Mm-hmm.
that life puts into an atmosphere and sends beyond its atmosphere. There are folks out there even just trying to find the excess infrared light that would be created by a solar system surrounded by a Dyson sphere, but we haven't found anything conclusive.
Mm.
And it's that phrase conclusive that matters so much.
Yeah. Oh, that was a brilliant little sidetrack from the technical questions earlier. But oh, that's a brilliant point. I am looking forward to hopefully living to the day and age that we do find microbes in our own solar system. That would be
Yes.
a amazing point to live through, if that makes sense.
It does.
Yeah,
I just wanna see fossil hunting on Mars. That's what I dream of.
that would be great. Um, Zier asked, apart from the lack of room, are there any benefits in parking scientific satellites in a lunar orbit?
Um, Not compared to other places we can stash them.
Okay.
So there are special orbital places where gravity balances out. These are called the Lagrange points because he's the person who did the math to begin with.
Oh, yes. We all got
Yes.
traumatized by Lagrange very early in mechanics. I still remember.
Yes, exactly, exactly. So when you start looking at the balancing points between the Earth and Sun, for instance, we like to stick solar satellites in the Lagrange point that's closer to the sun from us,
Hmm.
where they get balanced. They stay there as the Earth goes around the sun, so that there's always this sun Lagrange point Earth alignment. And when the sun shoots particles our way, they can give us warnings so that we have a time to safety our power grid and protect our astronauts. There's another Lagrange point on the other side that um, goes Sun Earth Lagrange point, and that's a great place to be putting telescopes because they follow us around, but they're far enough out that they're not getting all of the pollution from Earth that like Hubble has to deal with.
Mm.
Now, with the moon, if they're orbiting the moon it's messy orbital mechanics if you want to get someplace where your orbit is primarily driven by lunar gravity. You're fairly close, you're dealing with the moon's exosphere. It actually has a bit of atmosphere. It's particles that are largely suspended through electrostatic forces rather than the thermodynamics of our atmosphere. And that can all create drag on your spacecraft. You get the sunlight reflecting off of the moon. It's just not a great place to stick spacecraft, compared to all the other places
Yeah.
we can stick spacecraft, unless you're trying to study the moon, in which case, please do stick stuff in orbit around the moon.
Do we have many? Are you aware of if we have many probes or satellites orbiting at the moment?
Oh man, I don't know all of them at the moment. I know we still have Lunar Reconnaissance Orbiter.
Mm.
I'm not sure what other of the US missions might still be orbiting but not collecting data. We're pretty good at dropping things onto the surface, to be honest. I believe that China has a communication satellite to communicate with their far side probe, and I believe that India has a
Mm.
mission that they're using for communications, and I believe Japan still has an orbiter. There may be others that I've forgotten, and I can't guarantee the Japanese one is actually still functioning. I think it's still functioning, but I
Hmm.
could be wrong.
No, yeah.
I reserve the right to be wrong. At any given moment, there's a number of them. And especially as we're starting to drop satellites into permanently shadowed regions that don't get any sunlight. And as we're putting landers on the far side of the moon that never has line of sight communications with the Earth, having these communication satellites just allows landers to get a lot more communications for their buck, essentially.
Yeah. Okay, thank you so much for that. I have a weird question here, and I say weird, and I don't mean to call out science for this. Apologies. It's just I don't know what this question is. When we start looking for Boltzmann brains, if we haven't already, how would we find them in the data or we have or will need? Do you know what
Oh
Boltzmann brains
man,
are?
I did once and then I forgot,
Oh
and my
no.
brain is like, you should know this. You know that
Because
feeling you have
I
on a
know who Boltzmann is. I love the man, and I know what a brain is. I do not know what those two words in combination mean.
right, I knew this once. I now have Wikipedia open so I can
There.
read Wikipedia. The Boltzmann brain thought experiment suggests that it might be more likely for a single brain to spontaneously form in space, complete with a memory of having existed in our universe, rather than for the entire universe to come about in the manner of cosmologists think it actually did. So, this is one of those things that I think requires discussion at 5 a.m. when all boundaries have been lost, perhaps
A glass of wine.
with yes, yes, and preferably a philosopher and theologian also present so all things can be considered.
I see. Sounds like an episode from Star Trek, honestly, when I heard your
Yes.
description.
Yes, but this is where you go to 10 forward and you talk to, oh, I can't remember her name. Whoopi
Oh,
Goldberg plays
yes.
her.
Why is my I
She's the
just
one who would
finished.
know the answer.
Uh,
Um,
Guinan. Not
Guinan.
Neelix. Don't you
Guinan would,
Neelix me.
yes.
I've
No,
trauma.
not Neelix.
I don't like
That's
Neelix.
Voyager.
Yeah.
Uh,
Sorry. But this is great with or without the answer sign. So, do you want to express your opinion, or kind of like, look, I haven't really thought about it, to be honest.
so to me, it feels wrong. Like the idea of being created with memories and all of that intact, it just feels wrong. But I mean, this is something where it's saying that Sean Carroll pointed out that in a fluctuating universe, the scenario works just as well with entire bodies or even entire galaxies. And Sean Carroll is certainly smarter than I am. So I don't know. I can just tell you that my gut instinct, which is a lying liar so often, says no, no. But that's a gut instinct.
So yeah, just so I understand, it's not much more different than saying consciousness existing in a
Yes.
galactic form. Is that what I'm understanding from the statement?
Yes,
Okay.
but also coming into existence as like turning on a hologram of Moriarty in the holodeck, and that hologram has the full memory of the character from the books,
Wow.
but hasn't lived. And so the idea is a
Okay.
universe coming into existence with memories, but has never lived.
Okay. That's very very sci-fi in my
Yeah,
maybe
yeah,
more on the fi part.
yeah,
Okay.
exactly.
Well, look, today I learned. I never heard it before. That's really cool.
The
I
goal is to
learned
always
today.
learn.
We have a question. Do you have? Oh, I love this question because I had a very similar question. Do you have any reservations about humans colonizing the moon or any other celestial bodies in the solar system? I suppose before, if you want to answer that, maybe the question is, do you know what the situation is with the building the base of the moon at the moment is,
Yeah.
and then we'll go on to that part of the question, I guess.
So so I think we need to be careful in our language. We should not be colonizing anything. I would like to think humanity has learned better. I do think it is reasonable to, in working through the International Space Act, through the Artemis Accords, in collaboration with multinational cultures and countries to set up, as we've done in Antarctica, civilian research stations that are dedicated to trying to understand beyond our world. I have a lot of problems with thoughts of using everything as a consumable resource. The best argument I've heard so far is that when we do start lunar prospecting for needed materials, that we need to embed scientists with the prospecting companies the same way we embed archaeologists here on Earth, so that if something particularly interesting is found mid excavation, hopefully the science will be protected. But I don't think any of us honestly feel that if a company is out there prospecting whatever it is that is commercially viable for them, that if all of the sudden a cool meteorite crops up, they're going to stop everything for 3 months while we figure out what to do with it. The amount of money involved is just too great. So I really worry. I'm pro Science Outpost. I am pro treating the moon and Mars the way we treat Antarctica, as a shared place for peaceful science and tourism and exploration. And I get a little heartbroken every time someone starts talking about, well, what are the commercial reasons to go? I hate money. It just comes down to that.
Yeah, no, hearing you speak about that just always makes me think about do you know the Star Trek universe that, Earth lives by, and the fact that resources are needed and everyone just works
Yeah.
for the whole
Yeah.
purpose of fulfillment, and you don't,
Yes.
it's such an ambitious outlook in life, but hopefully one day.
All the research shows that a universal basic income improves education, economics, and creates small businesses. But we've been so brainwashed by the idea that everyone can have what they need if they only work hard enough, and that if you don't work hard enough, then clearly you don't deserve that thing you don't have, that we forget that billionaires often started out with rich parents, and that not everyone does have equal opportunities in this world. But that's a different show and a different topic.
No, no. Thank you so much for us getting a little bit sidetracked with that. That was a really good question to kind of summarize at the end. I have a little thing written down here. Have you watched or read the books or watched the TV show Three Body Problem?
I've read the books. I haven't seen the TV show yet.
You read the book. So I watched the TV show.
Yeah.
I got bullied by everyone because they're like, "You're a physicist. You love it." And I think because I was bullied, I didn't like it. So my question is, what were the books like? What is your opinion of them?
Oh, they introduce really amazing ideas, and they are so thick, and they have side quests, if that makes sense.
Yes, I can see that a little bit.
Side plots that I didn't enjoy as much as others. So there was definitely, ooh, this is the part I sit and read in detail, and this is the part I skim through. Sometimes you read things because they introduce you to ideas you wouldn't otherwise have ever encountered, but wish it had been done in fewer words. I think that's a fair way to sum it up. I'm glad I've encountered those ideas.
Yeah, no, looking back, I was very critical at it at first because a lot of the physics was flawed. But, like, I just have to watch sorry, I usually do enjoy things that are just sci-fi. Like, I actually am but I think this is another sidetrack. Someone told me to watch Game of Thrones because it is like Lord of the Rings. I went and watched Game of Thrones and it was awful because I had the expectation of it being as good as Lord of the Rings. So it obviously ruined it for me. So I think it's that kind of thing happened in my brain. Everyone told me, "Oh, you're a physicist, you're going to love this. The physics in it is really good and real." So I came into it critical And yeah. So that I recognize that I have a negative outlook on it, but I'm interested to hear what other physicists have to say about it. So I'm glad to hear that you say that you enjoyed the ideas and
Yes.
the sci-fi part of it, I suppose.
Yeah, it's in the books you're introduced through the video games and dreams
Mm.
to this completely unstable world where humans have to not humans, the life forms, the civilization has to desiccate to prevent being completely destroyed when the weather changes, and just looking at how they kept trying to thrive just kind of stuck with me.
Mm.
It's the inevitable, indomitable spirit of life to find a way.
Ah, to quote our favorite scene from Jurassic Park.
Exactly, exactly.
I always love referencing Mache as a I always butcher the pronunciation. Chaotician? K. Yeah.
I don't know how to pronounce it, but yes, someone who studies chaos theory.
Yes, and I went into actually studying chaos theory a little bit as a side project just to understand it. It's like, okay, this is interesting.
Yeah,
Anyways,
it's
sidetrack
wild.
there. I know that you have a scheduled appointment coming up soon,
I do.
so we are
Yeah.
going to be finishing towards the end. I suppose I'd like to. I'm so sorry for the last couple of questions there. Apologies. I'd just like to jump in to say, to ask one thing and then say one thing. To ask, basically, I know that you as Rocket Sage in our last Tofu Tech Talk told us, you're one of the OG science communicators, not even on
Yes.
Twitch, but on other platforms. Can you just share your wisdom and history, please, with us? We'd love to hear a little bit about this if you have time.
Yeah, so I started as a podcaster back in 2005 when the technology was only 4 months old. Back then, it was the podcast directory. Adam Curry of MTV VJ fame
Wait, was
was the
this before
one.
YouTube?
Yes. Well, YouTube, I think, started in 98, but it was
Oh,
before YouTube was popular.
I thought YouTube was 2005 for some reason in my head. I don't know why I had that.
I think that's when Google bought it.
Oh, I see.
Yeah, so YouTube was originally not owned by Google. It was its own thing. But this was before, so in October of 2004, um, RSS was developed as a technology where you could use the XML markup language to start to send enclosures to subscribers. And this idea that you could use technology to subscribe to something was completely new. And it was a researcher at Harvard who did science communications, or I guess it was actually finance communications, was the
Hmm.
first person to really start to create a podcast. And then other people, and in particular Adam Curry became kind of the evangelist for the technology, started trying it out. And in January of 2005, one of my colleagues who'd been reading Parade magazine came up to me after we had both just finished flying cross country for a conference and was like, okay, on the airplane, I read about this new technology, podcasting, that Christians are using to reach tech heads. I think we should use it to spread science. And within a month, we had gotten the microphones, we had written the scripts, we had recorded the episode, and we launched. And we were like, our goal is to try and get like 300 listeners. And then Adam Curry, as he did, listen to our show when he was listening it in the podcast directory, and they had to create the science and technology part of the directory for us. That category didn't exist prior to us. And he listened to our show and he talked about it on his show. And so suddenly we had thousands of people. And this was right when Facebook had just launched. And because I was working at Harvard, I had a Facebook account. And this was before Facebook pages when you could only do Facebook friends. And I'm suddenly getting all of these invites from podcast listeners wanting to be my Facebook friend. So this was before real social media. And then it was just like every time new technology came out, the question became, how do we leverage this for science? How do we leverage YouTube when YouTube became a major platform? How do we use social media? How do we use with Astronomy Cast, we got special early access to Google Hangouts, and they actually did an entire ad for Google Hangouts based on our online star parties that we were doing. And so I've basically built my career by saying, okay, I like to play with technology. Can I use it for science? And thus justifying my time playing with it. And it's getting to the point where it's just like, oh, no one wants to see this overweight, white, middle-aged lady on TikTok. But I'm trying to keep up with the cool young kids. But yeah,
TikTok is
I've been
rough.
there.
Yeah,
It
no,
it is.
yeah,
It is. I
TikTok is
think I've
rough.
posted 3 things. But yeah.
No, that is fascinating. That so you touched like so many forms of technology, experimented with it
Yeah.
all, basically.
It's my happy place.
Ah.
Although I was happier when everything was voice driven. This having to look good on camera is a whole lot harder than being a voice actress. But it's
Oh.
it's what we do.
No, that
It's what we
is
do.
fantastic. Thank you so much for obviously coming on Tofu Tech Talk. You were like, when I was scheduling with you, you were like bang on replying. And then like in 5 minutes, we had the Tofu Tech Talk scheduled. In 5 minutes. This was the fastest scheduled Tech Talk in history. I've never worked with someone so like on point. And you were the only person I had to cancel because I had something come up in a personal life. The only time in history. I thought it was funny. The side rant out of that, I just want to say that you've been a phenomenal guest. I don't know how my lab rats feel in the chat, but you speak so well. You
Thank you.
are articulate and lovely voice, by the way. I can see the voice aspect that you mentioned. Very,
Thanks.
like, just so nice to hear. But you're so articulate and explain everything well. I don't know about anyone else, but obviously I'm not, educated in the field of astrophysics. This is not my field. But you explained it in layman's terms, and I was able to be on board the whole way. And I really appreciate, your skill in
It's
being
my
able to do
pleasure.
that.
Thank you. And if any of all of y'all want to, I went to the University of Texas, all y'all comes out occasionally. If any of y'all, all y'all want to follow along, we are starting our new season of Escape Velocity Space News, evsn.tv. And Astronomy Cast is going to start having new episodes in September, and all of you are invited to come on the journey with us.
Would you be happy to share the link? Would that be okay
Yeah,
to ask you?
I'll go ahead and type them in. Yep.
Perfect. So while you're typing that in, I'm just going to tell Labras that we are going to go into the AFK screen for a couple of minutes, and I'll ask my mods to find a good raiding target to raid over. And of course, as always with Tofu Tech Talks, apologize on my behalf that I won't be able to say anything. I'll pin that to the top of the channel. If my mods could kindly find a raid target and also respond that I won't be able to go over there because I need to say my private goodbyes. No, I love the Texas part. So I don't know if you know, like my research is in grid and energy stability and electric grid stuff. And I always love talking about America just because,
Texas is, yeah.
there's three isolated grids in the US: the East, the West, and Texas. So fun to
Yep.
say. But again, thank you so much. Goodbye, my lab rats. I shall see you. Goodbye, Star Strider. Thank you so much.
My pleasure.